So here's a lab I did with my chemistry 30s today where we're taking a look at analyzing hydrogen peroxide. This is a common lab the diploma will refer to. So this lab, the first few steps, you're just going to grab your materials. So the H2O2, so the peroxide, we need a strong acid, and then we are going to take 10 mils of that hydrogen peroxide and put it into that Erlenmeyer flask. Then you'll use a graduated cylinder and take 5 mils of the acid and add it to that Erlenmeyer flask. And in your burette, we'll have the KMNO4. Then you will start to titrate, and it's a really dark purple. And when you start the titration, so like if you see here, you have that KMNO4 is very dark. And then this part here is when your titration's over. So as you're adding that dark purple in, it is that clear solution. It disappears or makes the purple disappear. And then that one drop will turn it into a very nice light pink. Now, I'm just going to make up a value here. When I did my demo, we were around 12.1 mils. Of course, you'll do 3 trials. Hopefully they're all around the same, but that's what we'll use for our analysis. So the first part we want to do is write our balanced redox equation. So you want to talk about what is reacting. And you have that K ion, that MnO4 ion, you have water present, you have H positive from the hydrogen with the sulfate, so SO4 2 negative, so I mean to say sulfuric acid. And then lastly, you have your H2O2. Now, when you take a look at page 7 of your data booklet, you will see that the MnO4 and the hydrogen together make your strongest oxidizing agent, and the H2O2 is your strongest reducing agent. So taking a look at that, we can write down some half reactions. And I just realized I needed a data booklet. So I'm just going to grab one. Oopsie. Okay, so I'm looking at page 7 of the data booklet. And the first reaction is that MnO4 with the hydrogen. So I'll start with that. And I'm just writing down what I see because this is what is undergoing reduction. Plus that 8 hydrogens plus 5 electrons. And then the products you're going to get are Mn2 positive plus 4 water molecules. So that's the first one. And then the other part I'm going to take a look at is for that H2O2. And because it's undergoing oxidation, I'm going to have to flip this reaction. So I need the H2O2 on the reactant side. And then I will start writing out that one as soon as I can see it. There it is. And so that is O2 plus 2 hydrogens and 2 electrons. All right, so from here we can add this together if we balance out our electrons. So we have to multiply the first reaction by 2 and the second reaction by 5. So I'm going to go ahead and write it down here. You'll end up with 2 MnO4 negative plus 16 hydrogens plus 10 electrons plus, going down to the next line, 5 H2O2. And then your products will be 2 Mn2 positive plus 8 water molecules plus 5 oxygen plus 10 hydrogens plus 10 electrons. Then we want to reduce what we can, and what we can reduce is the 10 hydrogens here with 10 out of the 16 on the left-hand side. You'll also notice that your electrons cancel. So now we have that balanced redox equation, and now we can start to organize our information. So with the MnO4, we do know the concentration. It's 0.008 moles per liter, so that was given to us. The volume used, as shown on the other page, was 12.1 milliliters. And then for the H2O2, so looking over here, we have the concentration is what we want to find, and each time we titrate, we're using 10 mils. So now we have enough information to apply the stoich, right? The part about MnO4 can get us to moles. Mole ratio, we'll turn it into H2O2, and then we can divide by our volume. So I'm just going to write that out. So to do that, I will have to turn my 12.1 into liters. So I'll have 0.0121 liters times the concentration, moles per liter. We'll see liters canceling. Now the times the mole ratio. So 2 moles of the KMnO4 is in the denominator. 5 moles of the H2O2 is in the numerator. And then lastly, I'm dividing by my amount of hydrogen peroxide used. So now that I have that, I can plug this all into my calculator, which I'm about to do if my calculator cooperates. So 0.0121 times 0.008 times 5/2 times, or not times, sorry, divided by 0.01. And we're getting the concentration as 0.0242, and that would be moles per liter. So that was my lab value, which would be my actual value. So over here, my actual or my experimental value is 0.0242 moles per liter. This part here is saying what I should be getting, which was 0.025. So now I can calculate my percent error. And the theoretical value has to be given to you. And then we'll multiply this by 100. So let's go ahead and do that. So I have 0.025 minus 0.0242 divided by 0.025 times 100, and I have my percent error is 3.2. So that's pretty good. Usually you want to be between 0 and 5. So if you're closer to 0, the better, because that means you're not wrong. The next part with question number 4, this is a good question because it's asking about why we're adding the acid to the hydrogen peroxide. Without the acid, right, we had that MnO4 negative, but if you didn't have acid, then together we would not have a strong oxidizing agent. So we need the sulfuric acid to get that hydrogen. If it's not present, then this reaction wouldn't take place. And then the last one, what triggers the color change at the end point? Well, there's no more MnO4 and the hydrogen, so your strong oxidizing agent is now, it doesn't have any more of a reducing agent to react with. So you still have SOA being added in, but your reducing agent, your strongest reducing agent, it's all used up. So without anything to react with, then that SOA, which is that bright purple color, will turn that solution purple. As always, I hope you found this helpful. If you did, please subscribe, and if there's any other video I can ever do for you, just let me know. Thanks for watching.